This screencast will demonstrate a practical example of model interpretation for the so-called Weighbridge domain. The purpose of this domain is to measure weight of vehicles. You will see how a Weighbridge system can be defined with a DSL and directly interpreted without any intermediate transformation steps. The model on the canvas is a simulation model, which means that all events that are external with respect to a Weighbridge system, for example, arrival and departure events, time progression, are predefined in the model and affect the model only. We start with a very simple model that contains an empty when arrival QEL, a timer showing system time currently at 0, and a single when main that is entering the arrival queue. Main is a special when whose tasks are to construct a Weighbridge system and predefine all incoming external events. We can see these tasks in the body of main. First task is to create a when behavior template from which the interpreter will create arriving vens. Next task creates a single Weighbridge named W. Finally, two vehicles are scheduled to arrive at clock times 0 and 2. Both vehicles are to be based on the above mentioned behavior template. Let us execute this model. You see execution controls appear on screen. To visualize how the Weighbridge system changes, the model is interpreted in the step-by-step mode. Let us make the first step. We see that main has entered the arrival queue. So far, it is the only when in the queue, that is the first and the last at the same time. Next, the interpreter will execute tasks defined by main. First, when template is created. As we see, there are three tasks: bridge access, weighing operation that takes 3 time units, and bridge exit. Next, the interpreter creates a Weighbridge W as defined in main. Then, when 1 enters the queue with arrival time 0, also, when 2 enters the queue with arrival time 2. Both carry the same task as defined in the when template. At this point, main departs because all its tasks have been executed by the interpreter. This completes the Weighbridge construction part. On a side note, those familiar with metaprogramming will recognize that the initial model was instructed to model itself at runtime to create a more complex Weighbridge model. Alternatively, the resulting model could have been constructed manually, without assistance of main. The rest of this demo is playing out the constructed system. With main being removed, next event at time 0 is arrival of V1. This when accesses the Weighbridge. Access is granted and V1 is being weighed for 3 time units. The bridge will remain busy until the operation is complete. The duration of weighing is simulated by V1 re-entering the arrival queue at time 3 after V2. Note how the interpreter sorted vens visually as well. Current time is still 0. No when is scheduled to arrive at the Weighbridge at this time, so the interpreter wants a system time. At time 2, V2 arrives and attempts to access the Weighbridge. Since the bridge is still busy, V2 becomes blocked and is moved to the delay queue. Again, there is nothing to execute at this time, so the interpreter wants a system time. At time 3, when 1 arrives again, which simulates the end of its weighing operation. In the next step, V1 exits the bridge. This event unblocks V2 and V2 re-enters the arrival queue at the current time 3 after V1. Then 1 has completed its tasks and departs. V2 proceeds to access the Weighbridge. The bridge is free and access is granted. To simulate duration of the weighing operation, V2 re-enters arrival queue at time 6. Time is advanced to 6 and V2 exits the bridge. Weighbridge becomes idle. V2 has completed its tasks and departs too. This concludes the model interpretation demo for the Weighbridge domain. In a follow-up, we will show how a Weighbridge interpreter was developed using a model-driven approach.